Thank you everyone to join the Techtion Smart online webinar. I'm Sylvia, and today I will introduce our reliable display terminal solutions for public transportation and smart city information systems. The main focus will be low power, sunlight readability, wide temperature operation, and outdoor reliability, especially cholesteric LCD digital signage, low power outdoor displays, local dimming, and optical bonding. Today we will cover three areas. First, smart transportation display applications, including passenger information display systems, bus stop signs, and digital signage. Second, outdoor display performance, including low power, sunlight readability, and wide temperature reliability. Third, practical solutions for customized display projects and long-term support. Let's begin with a short introduction. My name is Sylvia. I work as a sales engineer for smart transportation. My role is to connect each customer's application, environment, power, interface, installation, and maintenance requirements with a suitable display and terminal solution. My work mainly involves overseas project communication and customized display requirements. The purpose of this webinar is to connect smart city infrastructure needs with practical display choices, explain how low power, sunlight readable, and wide temperature designs support public transport projects, and show how Techtion Smart approaches customization, sample verification, and long-term cooperation. The webinar follows 6 sections: company context and application scenarios, outdoor performance requirements, product advantages, and engineering priorities, display technology selection, customization, and project delivery, and finally case reference, key takeaways, and Q&A. We will start with company capability and then connect it with passenger information, bus stop signage, and public information needs. Techtion Smart is the complete terminal business unit with Shenzhen Litech Electronics focused on customized display terminals for smart transportation, outdoor information, and other vertical market applications. Our product directions include all-in-one panel PCs, industrial monitors, e-paper, and cholesteric LCD terminals, reflective and transflective displays, outdoor high brightness terminals, and stretch bar display solutions. Our project value is to help customers select a suitable display technology, enclosure, platform, and power configuration according to the real installation environment.
Sorry to interrupt, but
the project starting point, whether the application is passenger information, bus stop signage, or public information, how frequently the content updates, the viewing distance and interaction requirements, and the installation environment, available power, and maintenance conditions. Then we define the solution direction by matching cholesteric LCD, e-paper, reflective or transflective LCD, high brightness TFT, local dimming or stretched displays. We also define the enclosure mounting interface, power, and system platform.
Hiya, the presentation isn't moving on.
Now let's go on. And we also defined the enclosure mounting interface power and system platform and confirmed the direction through sample verification before batch production. The following pages start from real transportation and outdoor applications and explain how each display technology responds to different project conditions. Sustainable infrastructure displays must be readable, in energy conscious and reliable in real operating environments. Cities and transit operators need terminals that can display information reliably over long service periods. Arrival delay, route transfer, and service information must be visible when passengers make decisions. Outdoor terminals may face sunlight, rain, heat, dust, vibration, and daily temperature changes. These conditions affect not only the panel but also the enclosure, ceiling, power supply, mainboard, connectors, optical stack, and internal heat distribution. Lower power consumption and easier maintenance help reduce long-term operating pressure, especially when many terminals are deployed. Public infrastructure projects also need stable components, repeatable production, and long-term service support. The design goal is therefore not only to show information but to keep it available with lower energy use and lower maintenance pressure. Passenger information display systems are used in platforms, waiting halls, stations, hubs, transfer areas, and vehicles. They need arrival, departure, route, transfer, and service information that remains clear in daily operation. Visibility requirements depend on the location. Indoor areas may use conventional TFT, while semi-outdoor areas may require high brightness optical treatment or reflective technology. Narrow vehicle space may need stretched bar displays. Suitable Techtion directions include high brightness, reflective and stretched bar display options, long-hour operation for transportation environments, and flexible structure interface and platform configuration. The terminal may also need to connect with transit data, a CNS, or a station control system. Bus stop displays need to balance low power, daylight readability, and field maintainability. Typical content includes text bars, arrival, routes, maps, transfer information, emergency notice, and public service updates. For low frequency updates, Cholesteric LCD is a key direction because it is reflective and bistable and can retain an image without continuous panel drive power. E-paper is also suitable for ultra-low power static or scheduled timetable updates. Reflective or transflective LCD uses ambient light to support readability. High brightness TFT or local dimming is more suitable when dynamic full color content, animation, or advertising is required. The complete solution may need solar-ready design, IP protection, and wide temperature consideration. Low power is not only a screen specification, it only includes solar and battery capacity, sleep and wake strategy, network behavior, thermal design, front glass treatment, mounting, and field replacement. Outdoor digital signage can combine city notice, device updates, emergency messages, maps, directional guidance, accessibility information, transit hub media, and scheduled promotional content in one terminal. If the content is merely periodic public information, cholesteric LCD can provide a low-power reflective solution. If the terminal needs video, rich animation, or high-impact advertising, high brightness TFT or local dimming is more appropriate. Content management is also part of the solution. The CMS can schedule content, update information through the network, manage emergency priority, and support maintenance planning. Reliable outdoor terminals depend on display performance, power design, mechanical structure, and verification. A reliable terminal combines six areas. First, energy efficiency through low-power display architecture, licensing, low standby power, and solar-ready design. Second, sunlight readability through high brightness, reflective or translative technology, optical bonding, and AR surface treatment. Third, wide temperature design for hot, cold, and semi-outdoor operating conditions. Fourth, outdoor structure through IP protection, rushed enclosure, stable mounting, and reliability verification. Fifth, system flexibility through multi-mode, Android, Linux, Windows, ARM, or x86 platforms. Six, project customization covering size, structure, interface, cover glass, touch operating system, and power configuration. For smart city infrastructure, the display terminal should be selected as a complete system, not only as a screen. Optical readability includes brightness strategy, optical bonding, surface treatment, and automatic brightness adjustment with a light sensor. Mechanical protection includes front side or full enclosure IP options, rush structure, installation strength, and suitable materials for outdoor or transportation use. Outdoor reliability should be evaluated together with optics, thermal management, ceiling interface, structure, and maintainability. Higher brightness increases power and heat, stronger ceiling changes heat and pressure behavior, and thicker cover glass can increase reflection if the optical stack is not designed correctly. The right display technology depends on the content, update, rhythm, lighting condition, power mode, and installation space. For static or periodic information, cholesteric LCD and e-paper provide very low power sunlight readability and an eye-friendly viewing experience. Typical applications are bus stop timetables and public information boards. For outdoor or semi-outdoor information terminals, reflective or transreflective displays use ambient light and reduce depends on the backlight. They feed outdoor terminals, ticketing, payment, and traffic management applications. For dynamic full-color public information, high brightness TFT offers approximately 1000 to 3000 nits, rich color and optional patch for PIDS, signage, and wayfinding terminals. For prominent outdoor advertising and information displays, local dimming uses dynamic backlight control to improve contrast and provide energy-saving functional. For onboard PIS and route guidance, stretched bar displays provide custom aspect radio compact routing and anti-vibration oriented design. No signal technology is best for every project. The correct choice is the one that meets the information need with the lowest reasonable energy use, the engineering complexity. Now I would like to focus on one of our key product directions, cholesteric LCD digital signage. The TS315 PHDC is a 31.5-inch reflective cholesteric liquid crystal display for passenger information station and ticketing information and public information terminals with periodic content updates. It has a resolution of 1920 by it has a resolution for 1920 by 1080 and 178-degree viewing angle. Its most important characteristic is bistability. After an image is written, it can remain visible without continuous panel drive power. This is very different from a conventional TFT LCD, which normally needs continuous driving and an active backlight. The display is also reflective, so it uses ambient light instead of depending on a strong backlight. In bright outdoor environments, stronger ambient light can support visibility rather than only creating glare. This connects sunlight readability directly with low power. A full image refresh takes approximately 1 to 2.5 seconds, and the specified power during a full refresh is below 8 watts. The product direction supports meanings 30 to plus 85 degrees Celsius and visa mounting. Because of the refresh behavior, this product is not designed for continuous video. It is best for static or semi-static information such as route, maps, timetables. live information, platform information, ticketing guidance, public notice, and smart city information. We should also distinguish panel power from complete terminal power. The controller network, 4G or Wi-Fi sensors from lighting if include and scheduled updates still consume power. For this reason, the complete terminal should have clear sleep, wake up, communication update, and confirmation logic. When the content written is suitable, characteristic LCD can reduce average power, simplify solar and battery planning, and reduce thermal pressure compared with a continuously high brightness backlight display. We did therefore see cholesteric LCD not only as another display panel but as a different energy architecture for outdoor digital signage. E-paper is best when content is static, scheduled, or focused on information continuity rather than video. It is sunlight readable and eye-friendly, uses very low average power in static mode, and is suitable for solar or battery-assisted deployments. Typical applications include electronic bus stop signs, static timetable boards, and public information boards where the refresh frequency is limited and lower maintenance is a priority. The choice between cholesteric LCD and e-paper depends on color requirements, refresh time, operating temperature, size, from light needs, viewing experience, supply availability, and cost. Reflective and transflective LCDs provide a practical option when ambient light can support visibility. A reflective LCD mainly uses ambient light while a transflective LCD combines reflective and transmissive behavior so the backlight can support an image in lower light conditions. This direction can improve daylight readability with lower backlight demand and is useful when the project needs color display and lower energy consumption. Typical applications include outdoor self-service terminals, intelligent ticketing and payment systems, outdoor traffic management terminals, and public information terminals in semi-outdoor spaces. The final result also depends on cover glass, polarizer, optical bonding, anti-reflection treatment, viewing angle enclosure, and the real ambient light environment. High brightness TFT is the most flexible direction for dynamic full color content. It can support approximately 1000 to 3000 nits video animation, touch, and Windows, Android, or Linux platforms. Optical bonding and ivy-rated structures can be added for outdoor projects. Logodimi is designed for preeminent outdoor displays and can support a higher brightness direction. The LCD backlight is divided into multiple independently controlled zones. The system reduces light behind darker areas and increases light behind brighter areas, creating deeper black, stronger highlights, and higher perceived contrast. Logarithmic also support energy saving because the complete light does not need to operate at the same level. The actual saving depends on the content, target, brightness, tone, design, and control algorithm. A dark interface with bright information elements may benefit more than a full white image. This makes logo dimming suitable for outdoor digital signage, prominent passenger information transportation, hub media and high impact in advertising or public information content. Optical bonding or full lamination removes the air gap between the LCD and cover glass with a transparent adhesive. It reduces internal reflection, improves display clarity under strong ambient light, and supports a more integrated front structure. The bonding result depends on adhesive control, cleanliness, bonding thickness, curling time, pressure, bubble control, edge quality, and inspection. Logo dimming controls the light generated inside the display, while optical bonding improves the optical path between the LCD and the viewer. Together with suitable cover glass treatment and thermal design, they can significantly improve outdoor visual performance. Stretch bar displays are designed for route maps, next station information, and narrow installation space. They use in buses, metro vehicles, light rail, and rail systems for route guidance, door status, public messages, and advertising. Typical size directions include 28.6, 36.6, 37.6, and 57.6 inches. 6 for CMS or control system updates and compact mounting in long, narrow space. Transportation integration also requires attention to mounting strength, vibration, power input interface, content control, heat, and maintenance access. After selecting the display technology, the next step is to turn it into a complete terminal defined by the application, environment system, and lifecycle requirements. Customization can cover 6 layers. Display parameters include size, brightness, touch, bonding, and AG or AR treatment. Mechanical structure can include open frame, visa mount, panel mount, pole mount, and customized metal housing. Lifecycle support includes sample testing, mass production, preparation, components, status management, and after-sales support. The key is to mesh all elements together. A low-power display with an inefficient, always-on communication system may not create a low-power terminal, and a high-brightness display without suitable thermal design may reduce long-term reliability. A display terminal project may include 4 system layers. The customer platform can be a transit data system, city information system, advertising CMS, or integrated platform. The content management layer handles scheduling, update, workflow, and maintenance reports. For a low-power cholesteric LCD or e-paper terminal, the system should define when the device reaches download data refreshes the image, confirms the update, and returns to low power mode. For local dimming settings may include brightness schedules, light sensor behavior, and content-related backlight control. Integration support should make the project easier to deploy and maintain. Our delivery path has 4 stages. First, review the scenario, environment, display technology, power, and installation needs. Second, prepare the proposal through platform selection, structure, concept, interface review, and cost evaluation. Third, validate optical, thermal, mechanical, electrical, software, and system compatibility. Fourth, prepare production through bomb freeze, process control, aging test, and delivery management. Before scaling, we clarify brightness, melting power, environment interface, and certification expectations, and verify the important optical, thermal, mechanical, and system risks. Outdoor operation depends on testing, traceability, and process discipline. Production control includes a controlled workshop environment, defined assembly and inspection workflows, and serial number traceability for shipment and after-sales support. Verification items may include a 48-hour aging test, high and low temperature testing, humidity, rain, and other reliability checks. For outdoor products, we review IP protection and sealing, mounting strength and vibration, thermal stability, and optical stability. For high brightness and low dimming products, we also review brightness, color, temperature, uniformity, backlight behavior, temperature rise, and long-term stability. For optical bonding, we inspect bubbles, particles, edge quality, touch performance, and optical clarity. For clustered LCD and e-paper, we may verify refresh behavior, image retention, communication reliability, low power mode, temperature performance, and recovery after power or network interruption. The goal is to improve consistency before shipment and reduce maintenance pressure after deployment. The relevant combination depends on the product. A vehicle display may require more emphasis on vibration mounting and power behavior, while an outdoor component may require stronger attention to rain, dust, UV, temperature, and sealing. A low power terminal should also be evaluated in its real operating cycle, including communication wake-up, image update, standby consumption, and battery behavior. A local dimming display should be tested with representative content, only a full white image, and optically bonded assembly should be checked after temperature and humidity exposure to confirm that the optical stack remains stable. During production preparation, we support process review, bomb freeze, agent tests, and delivery coordination. After delivery, we assist with replacement planning, quality feedback, and project continuity communication. Customers gain faster technical alignment, lower sample verification risk, and a smoother pilot to batch handover. Our support principle is to reduce project complexity and improve decision efficiency. In the final section, I will share select transportation and outdoor display cases, followed by our cooperation value summary and Q&A. Now I would like to share 3 selected outdoor bus stop and public information references. The Suzhou Industrial Park electronic bus stop sign project used a 32-inch display with a reference quality of 118 units. The Fuzhou e-paper bus stop sign project used a 31.2-inch display with a reference quality of 56 units. The Hainan electronic bus stop sign project used a 55-inch display with a reference quality of 25 units. These projects represent different size and technology directions, but the project logic is similar. And this shows selected, stretched, and onboard display reference for passenger information applications. The metro reference includes Shenzhen Metro with a 37.6-inch display and 300 units, Changchun Metro with a 37.6-inch display and 600 units, and Indonesia Metro projects with a 38-inch display and 240 units. The bus reference include Jiangxi Yanchang bus with a 28.2-inch onboard information display and 200 units. Hunan Zhangjiajie bus with a 28.6-inch display and 300 units, and Zhejiang Ningbo bus with a 36.6-inch display and 155 units. This project used long, narrow display formats for road maps, next station information transfer guidance, service messenger messages, and other transportation content. The stretched format makes effective use of the space above doors along vehicle interiors or inside narrow station structures. To summarize Techtion Smart's project value, I would highlight 5 points. First, we focus on relevant product directions. And second, we treat outdoor performance as an engineering system. And about sunlight, readability, wide temperature design, IP protection, optical treatment, thermal management, power and maintenance must support one another. Third, we provide project fit customization, display structure mounting, interface power, and platform are reviewed according to the actual installation environment. Fourth, We support technical review, sample validation, production preparation, and after-sales coordination. Fifth, we focus on long-term project value through lower energy use, reliable operation, and maintainable terminal design for infrastructure projects. First, define the scenario before choosing the display. Passenger information bus stop signage and public information terminal do not have the same requirements. Second, evaluate parameters together. Power, readability, temperature, protection, structure, interface, and maintenance should be reviewed as one system. Third, match the technology to the content, update, rhythm, and environment. Choose cholesteric LCD, paper, reflective or transflective LCD, high brightness TFT, logo dimming or stretch display according to the real application. Fourth, prepare for implementation, customization, sample verification, production handover, and lifecycle support. Determine whether the solution can scale. Sustainable display design is not about forcing every screen to use the lowest possible power. It is about selecting and the right display architecture for the real content and building a reliable, complete terminal around it. Thank you for your attention. Now please feel free to ask any questions. I will collect the questions first and answer them together in 5 minutes. If no one to ask some questions, and you can contact details for Techtion Smart are shown on the screen. After the webinar, you are welcome to send application information, drawings, technical requirements, or project questions to our sales team at sales@techtionsmart.com or visit www.techtionsmart.com. Our team will review the project conditions and help identify a suitable display and terminal direction. And thank you again for joining today's webinar. Techtion Smart aims to be your reliable, eco-friendly display terminal partner. We look forward to supporting future smart transportation, outdoor digital signage, passenger information, and public information projects. Thank you again, and I look forward to staying in touch. Thank you. That's all.